Hello. Okay, so today we'll be doing the third lab experiment. I've got the configuration over here. So this is what we're going to do. So what we're going to do in this is that we're going to do subnetting in this experiment. So basically when you take IP addresses from a network, basically when you get IP addresses, then when you have a lot of users in your network, you need to subnet those IP addresses so there's no waste of bandwidth. Because you get limited IP addresses, you need to efficiently use those IP addresses, and that's why we do subnetting. So we have this network. So basically, we have basically the entire layout of a network over here. What we have is we have four networks over here. Okay. So this is over here. We have the first network. Yeah. So over here we have the first network. This is the second network. Then we have a third network here between these two routers, and we have a fourth network here between these two routers. So we need four. Basically, we have four networks. So we'll be needing, as you can see, I have created this over here to explain. So we'll be requiring four networks. So we'll have to do the subnetting for these networks. Say route C. According to what we've done over here, say the network 1 requires 40 PCs, network 2 requires 25 PCs. Over here, this network will be requiring only 4 IP addresses, that is for the routers and for the broadcast and network ID. And over here also, these will be requiring 4 IP addresses, that is for the routers, respective routers, and for the network and broadcast IDs. So yeah, let's start. So I'll explain the subnetting part. What happens is basically, as you can see, we have total 256 IP addresses available with us, and we need total 4 networks. So let's start with this network over here. This, yeah. Let's start with this network over here. So this network, the first network, requires 40 PCs. So 40 PCs will be requiring the 40 IP addresses, plus we need 3 IP addresses for this router over here, for the switch over here, and for the DHCP server over here. After that, apart from that, we also need 2 IP addresses for the broadcast ID and the network ID. So in all, we need 45 IP addresses total. So let's allocate our to basically get those 45 IP addresses. We need to allocate a block of 64 IP addresses to this network, and a block of 256 IP addresses is split twice to get a block of 64. So we'll be allocating this IP addresses. We'll be allocating IP addresses 198.20.20.0 to 198.20.20.63 to this network 1 over here. So 64 devices, so we need 6 bits in the host address. So basically, there are 8 bits in the host address, and we need to steal 2 bits from the host address for a subnet. So the total network bits become 24 plus 2, that becomes 26. As you know, there's a formula 2 raised to n for, yeah, for the for all those host bits and subnet bits. So 2 raised to n, basically 2 raised to 2 is equal to 4, and we need 4 networks, so n becomes 2. So we steal 2 bits from the host bits part for our network. So 24 for the network and 2 for the subnet. So we have total 26. The subnet mask will be 255.255.255 plus 0.128 plus 64. 64 IP, because we have 64 IP addresses. So the subnet mask becomes 255.255.255.192. So yeah. So the network, so as you can see, this is what we have. These are the IP addresses that we have. The first 4 IP addresses will be allocated to the network ID, the router, the switch, and the DHCP server. So the first one, 98.20.20.0, is for the network ID. /26 indicates the network bits, and router 198.20.20.1 is the router IP address. Switch IP address is 198.20.20.2, and the server IP address is 198.20.20.3. Always the last IP address of the block that we have, the IP address block we have, is allocated for the broadcast domain. So here we have the IP address for the broadcast IP, 198.20.20.63/26. So let's move on to this network over here, the second network. For the second network, we had 25 devices in our network, and as mentioned earlier, we need 3 IP addresses for the switch, DHCP server, and the router, and 2 IP addresses for the network ID and broadcast. So basically, 25 plus 3 plus 2 gives us 30. So we need to allocate a block of 32 IP addresses to this network. So we'll be dividing a 64 IP block for this. So we have 998.20.64. From till here we had 63 the IP address. So from here we have 198.20.20.64 to 198.20.20.127 block. That will be divided. 64-bit block, 64 to 127 will be divided further. So we have the block as 198.20.20.64 to 198.20.20.95 because we need 32. So 95, 64 to 95 will be allocated to this network over here. So basically, yeah, so we'll be 32 devices. We have 32 devices. So we'll be requiring 5 bits in the host address, and apart from that, we'll be stealing those 3 bits from the basically we'll be stealing 3 bits from the host ID as explained earlier. And so we have 24 plus 3 is equal to 27. So now total network bits that we have is 27. 3 we stole from the host for our subnet. So we have the subnet mask is 255.255.255.198 127 sorry 128 plus 1 plus 64 plus 32. So we have it as 255.255.255.224. So basically the network ID for this will be 198.20.20.64, the first IP address. The router ID will be 198.20.20.65. The switch IP will be 198.20.20.66, and the DHCP IP will be 198.20.20.67. And the last IP address of the block will be 198.20.20.95. That will be allocated to the broadcast domain, right? So yeah, now we have the third network and the fourth network. Third network over here, fourth network over here. As mentioned earlier, the routers require 2 IP addresses, and apart from that, they require network ID and IP address for the network ID and for the broadcast domain. So we allocate a block of 4 IPs to both the networks. We require 2 bits in the host address. So the subnet mask becomes /30. So it becomes 255.255.255.252 as explained earlier. So network 3, the IP address is allocated to network 3 will be 198.20.20.96. Here the last one was 95. So here it will be 96 to 198.20.20.99. The network IP will be 198.20.20.96. The routers will be allocated addresses 198.20.20.97 and 0.98, and the broadcast domain will be the IP address will be the last one 198.20.20.99. Similarly, the fourth over here, right over here, yeah, over here, this one. This one will be 198.20.20.100 and to 198.20.20.103. These are the IP addresses allocated to the fourth node. So the network ID will be 998.20.20.100, 198 routers will be 998.20.20.101 and 198.20.20.102, and the broadcast IP address will be the last one 198.20.20.103. So this is what we have as the config as this is what subnetting is. So as you can see, we have already configured the routers over here with the IP addresses that we mentioned over here. Like router 0 has 198.20.1, router 1 has 198.20.20.101. The switch over here has an IP address 198.20.20.2. The router over here has 198.20.20.1, the first one over here. The second one is allocated to this switch over here. Similarly over here, the switch has 198.20.20.65 as the IP address, and router over here has 198.20.20.66 over here. And let's move on to the DHCP servers. The DHCP servers will be allocating the IP addresses to these networks over here dynamically, and this DHCP server will be allocating the IP addresses to these PCs over here. So let's click on this. Yeah. So we go to config. No, we go to desktop. We go to IP configuration. We set the IP address for this. As you can see, 198.20.20.3 is the IP address. We have the subnet mask, we have the default gateway and the DNS server. When we go to services, we go to DHCP. DHCP is on. The start IP address should be 4. 198.20.20.4. As till third, it has been allocated. The first one is allocated to the router, then to the switch, and then to the server. So from fourth onwards, we'll be giving 198.20.20.4 onwards will be allocated to these PCs dynamically. We have 45 PCs. Basically, not 45, basically 45 users, not 45. Maximum number of users 45. So we save this over here. Similarly, in the server, DHCP server, we go to desktop, we go to IP configuration. You can see this is the IP address 198.20.20.67 as mentioned over here. We have the subnet mask 192.55.255.224 as mentioned over here to 55.255.255.224, and we have the default gateway and the DNS set. Then we go to services, we go to DHCP, and this should be 68 because still 60, yep, should be 68 because basically 66, 67, 65, 66 and 67 are allocated to the switch router and the servers, so 68 onwards will be given to all these PCs over here, the IP address. So let's go to, so everything is set, everything is configured properly. So let's try to ping a PC. Let's try to first see if one of the PCs go to desktop, we go to IP address. Let's see if it gets us DHCP allocates IP address or not dynamically. So yeah, so it is allocating the IP address dynamically. This one, PC85 over here. Let's go to PC49. C49, we go to IP configuration, static, initially it was static, then DHCP, and it's working. The DHCP is working and it has been allocated this IP address. So let's try to ping this PC85. We try to ping from PC85 to this PC49. The IP address is 198.20.20.70, and here let's go. Let's go ping 198.20.20 was 0.70. So yeah, 0.70. First one will be timed out, and everything is working after that. Everything is, the first one is lost. That happens when you do it for the first time. After that, the packets have been sent and the 3 have been received. Let's try it again. 28.20.20.70. Yeah, reply. So you're getting a response, and all the packets have been sent and all the packets have been received. So this is how you do subnetting. You can ping any of the PC from this subnet to any of the PCs to this in this subnet. So yes, this is how subnetting works. So we're done. Thank you.